Seneca is good, but like in a way it doesn't really teach you something, so that's what we're using. Atomic model. The basic atomic model is the proton and neutron in the middle, then electrons orbiting it. So because they're orbiting it, they are said to be in orbitals or shells. The nucleus is very dense, whereas the overall atom is 99% open space and nothing. So whereas a small positively charged nucleus surrounding by orbiting negatively charged electrons, that is an atom. An atom has that. Which of the following statements are true about atoms? Protons orbit the nucleus or electrons? Electrons. They have a positive or negative. They have more protons, so it's positive. They're quite large. No, they're not. They're tiny because they make up everything. So the structure of an atom. Atoms are very small and have a radius of about 1 × 10 to the minus 10 meters. The electrons are arranged at different distances. So obviously that is the nucleus. And then one electron shell could be there, the other could be here, and the other could be here. So the obvious thing is the distance from here to here is different from the distance from here to here, and it's different from the distance from here to here. Simple. The radius of a nucleus is less than 1/10,000 of the radius of an atom. So if you times the radius of the nucleus by 10,000, you will get the radius of the entire atom. And most of the mass is in the nucleus. That's because the nucleus is very dense, has a lot of things which are very tightly packed together. So where's most of the mass of an atom found? In the nucleus, the electrons that spread equally, the energy levels, so it's obviously the nucleus. Simple. Size of an atom versus a nucleus. Atom has a radius of about 1 × 10 to the minus 10 meters. However, the nucleus is very small, even smaller. So obviously, if a nucleus was the size of a pea, then the entire atom would be the size of a football field. So there are 3 different subatomic particles, protons, neutrons and electrons, and they have different relative charges and masses. Atoms overall have no charge. So from GCSE you know that, brilliant drawing there, you know that as well, protons, neutrons and electrons exist. Protons have a charge of +1, neutrons have a charge of 0, and electrons have a charge of -1. So this now changes. Protons now have a charge of 1.6 times 10 to the minus 19. Neutrons now amazingly have a charge of 0. This is by the way in coulombs. And electrons have a charge of minus 1.6 times 10 to the minus 19. So it's literally protons times -1. And mass, you know protons have a mass of 1, neutrons have a mass of 1, and electrons have a mass of 1/2k or 2000. But that now becomes, that 1 is now 1.67 times 10 to the minus 27. The neutron is now 1.67 times 10 to the minus 27. I appreciate that. And the electron is now 9.11 times 10 to the minus 31. Simple. So these are all in kilograms and you need to know these. So that is basically the whole premise of what it just says. So relative charge of subatomic particles. Fill these out. Stopped. Now go. Proton, neutron, electron. Because obviously these are very self-explanatory if you're doing A level. So subatomic particles, what are they? They are the 3 things. So that's proton, neutron, and electron. There are obviously others, but overall, what do you call small negatively charged particles that orbit an atom's nucleus? Electrons. There's nothing else that's negatively charged. Well, ions are negatively charged sometimes. So this bit is what we've just been through. Which of the following has largest mass? Nucleus or an atom? Obviously the atom includes the nucleus, so it's bigger. But in regards to specific charge, we don't incorporate the electron's mass because it's too small to actually matter. Whereas most of the mass of an atom found, the nucleus, bears obviously the most dense part. What is the overall charge of the nucleus of an atom? It is overall neutral, so 0. Don't crash. Oh, nucleus. Well, I don't actually know what just happened. It just all stopped. So, which of the following are true? Overall, the nucleus is positive or neutral? Positive. I thought that said atom. Neutrons have a relative charge. Nope. Protons do. Neutrons have a relative charge of 0, and electrons have a relative charge of -1. Lovely. So now, end of topic test. The atomic model. That's what we shall do. What kind of charge does the nucleus of an atom have? +1. Positive. Theoretically, it could be a lot of things, but anything with plus in should work. What part of the atom contributes to negative charge? That would be the electron. Which of these statements are not true? Nuclei are very small in radius. Atoms have a positive nucleus. Neutrons orbit the nucleus. Nuclei are very large. Atoms have a negative nucleus, and electrons orbit the nucleus. So obviously this is true. Atoms orbit the nucleus, that is true. Electrons orbit the nucleus, no. They're not very large, and atoms do not have a negative nucleus. They have a positive nucleus because of protons. What is the approximate radius of a nucleus relative to the atom? 1/10,000. Yes. Where is most of the mass of the atom located? In the nucleus. Open. How are the electrons in an atom organized? They're organized in shells which orbit the electrons. Thus they're called orbitals. In orbitals, or orbitals, however you want to say it. Which subatomic particle has a relative atomic mass of 1/2000 electrons? Which of these statements are true? Electrons have a relative charge of +1. Neutrons have a relative charge of +1. Protons have a relative charge of +1. Protons have a relative charge of 0. Neutrons have a relative charge of 0. Electrons have a relative charge of -1. So that is true. And protons obviously have a charge of +1. Well, 1.6 times 10 to the -19. But who's counting? What charge does an atom have? 0 is neutral. 0 will probably get you more credit. So units for specific charge. Specific charge is charge over mass. So charge over mass, obviously. What term means per unit mass when describing the charge of a particle? Specific. Which of these statements are not true? Hydrogen cannot have 2 protons because that would just make it helium. What is the difference between a neutron and an atomic number? So basically the neutron number is the amount of protons plus neutrons, and the atomic number is the number of protons. So something number is the total number of protons and neutrons, nucleon. The number of something tells us what the atom is, protons, but neutrons can change in isotopes while protons cannot. Simple. Next, specific charge, protons and neutron numbers. So exactly what we just did in the last half of that test. So let's get it. Specific charge, protons and neutron number. Specific charge. Charged particles can be described in terms of their specific charge. Specific charge is charge divided by mass. So it is the ratio between the charge and the mass. So as far as sodium goes, it has 23 protons. So that's 23 times 1.6 times 10 to the -19 will be its charge. And its mass would be, for God's sake. It would be 23 times 1.67 times 10 to the -27. So, its specific charge is charge over mass. What is the specific charge of a neutron? 0, but obviously it has no charge and it has mass. So 0 over that, 0 over the mass would be 0. So proton and neutron number. Proton number and neutron number tells us information about the atoms. Proton number tells us the amount of protons and what actual element is it. Neutron number tells us the amount of neutrons and protons, would tell us the amount of stuff inside the nuclei, and would also tell us what isotope it is, what isotope the element is. So, which of the following are true about proton and neutron numbers? Well, we've done this one. The proton number identifies the element. The neutron number is fixed for each element. No, it isn't, by isotopes. The other two are true. We've just done this. What term means per unit mass? Specific. The neutron number, A, is the amount of protons and neutrons. Wow. What is a neutron number? Amount of protons and neutrons in a nucleus. Simple. Simple stuff right here. Easy. Now isotopes. Atoms of the same element always have the same number of protons, but atoms of the same element can have different numbers of neutrons. These are called isotopes. Hydrogen has 3 of these, so you need to actually learn all 3. So they're protium, deuterium and tritium. That's how I'm going to remember them. So protium is 1 proton, 0 neutrons, and are used in fuel cells to make plastic. Deuterium, that's short, I'll call it deuterium, is 1 proton, 1 neutron, and it's used in nuclear fusion. And tritium, that's how I'm going to say it, has 1 proton, 2 neutrons, and is used in thermonuclear fusion weapons. So, the atomic number of sodium is 11. How many neutrons does an isotope with a mass number of 12 have? 12? 22 have. 21. 11. Simple, because 22 minus 11. Isotopes are formed of an element that has the same amount of protons but different amounts of neutrons, because protons are obviously things that define an element. Nuclides, these are different types of isotopes, so isotopes are differently called nuclides. A nuclide refers to a specific nucleus that contains a certain number of protons and neutrons. For example, carbon 12, 13, 14. Carbon 14 is actually very significant because obviously, well, you wouldn't know this, it's used in carbon aging. Basically, carbon 14 is actually reactive. So, say when a thing is still alive, it takes in CO2. But when it dies, there is no longer an income of CO2. So that means that in its body there is a lot of CO2 molecules which are just floating around doing nothing, and these CO2 molecules are radioactive. So over time these radioactive molecules become half, and then they go through half-lives, and then after they go through half-lives they slowly become smaller and smaller. So depending on how many half-lives it's been through, so in this case this one has been through 1, 2, 3, scientists can tell how old something is based on how many half-lives its carbon 14 atoms have been through. Simple. So what's the name of a specific isotope? Nuclide. So which of the following is not a naturally occurring isotope? So there's carbon 11. That's just general knowledge that you should know. So we have just been through this. The younger the fossil is, the fewer. No, the older the fossil is, and the less radiation it emits. So basically half-life is basically a way of just, radiation is the process of trying to get rid of stuff so your atom becomes more stable. Obviously that is the process of just emitting radiation. Once an organism dies, it no longer absorbs carbon from the atmosphere. atmosphere. How many hydrogen isotopes are there? 3. There probably could be more, but we don't know. So what are they? They are protium, deuterium, and tritium. Simple. Carbon nuclides have different something numbers, but the same something number. So carbon nuclides have the same proton number. I literally said same. Have different nucleon, but the same proton number. A nuclide is a specific isotope of an element. The most common isotopes of carbon are carbon 12 and carbon 13. You know that because carbon 11 has to be man-made, and carbon 14 is just there in humans. So, this carbon dating examples, you can use them to be able to find information about climate change and the age of dinosaur fossils. Uses of death for that. Okay, carbon dating. So, all living organisms have the same amount of carbon-14 atoms as a percentage of all carbon isotopes. Once the organism dies, it no longer absorbs carbon from the atmosphere. Carbon-14 is radioactive, so over time will decay. Simple. Where did I put a water bottle? Where is this? That's there. That one took quite a while, you know. So, unstable and stable nuclei. So, strong nuclear force in an atom's nucleus. The strong nuclear force is basically the glue. It holds protons and neutrons together in the nucleus of an atom. So, the stability of a nucleus. The nucleus is positively charged because it contains neutrons, which have no charge, and protons, which are positively charged. Obviously, two things which are alike attract. So without the strong nuclear force, the neutrons would break apart because of the electrostatic repulsion, as obviously because the protons are like this, and they have the plus, so they are the same charge, so they would repel. Whereas when you have the strong nuclear force, it kind of like barricades this repulsion to make sure they are friends. Simple. Just remember it like that. Short range forces. The strong nuclear force only works over very short distances. Its optimum is 1 femtometer. It doesn't work in 0.5 femtometers. And after 3 femtometers, the strong nuclear force is too weak to overcome the repulsion. Repulsive at very short distances, that word just said. 0.5 femtometers, the strong nuclear force just doesn't work where the protons are too close together. And this is the same for every nucleon, doesn't matter what it is. At separation of about 0.5 femtometers and under, the strong nuclear force becomes repulsive. Simple. So we have just done this. So unstable nuclei, there are 2 types of decay, alpha and beta. I'll just explain them here instead of going from reading because animation is so much better. So, say you had the element lithium, I think that's 7 and 3. Pretty sure it's because there's 2 and then there's 1 in the outer shell that makes that. Yeah, I think it's 7 and 3. Lithium. So, this can either undergo alpha decay, so that's 4 to alpha, or it can undergo beta decay, also known as electron, and alpha decay can also be known as helium. And when this happens, the lithium 73Li in alpha decay would then lose 4 from the top and lose 2 from the bottom, and would become hydrogen with plus 4, 2, where they haven't gone anywhere. So they're still there, and this, in this case, would be tritium. Whereas 7,3 lithium in beta decay would be 7, 4, so that would be hydrogen, helium, lithium, beryllium. I don't know, beryllium maybe, and that would be plus 0, minus 1, and that would be an electron, because beta decay is literally losing an electron. So, in alpha decay, 4 nucleons are lost to form alpha particles, 2 protons are lost, so the initial atom becomes a different element. Well in, I guess. How far can a strong nuclear force reach? Over very short distances. Which of these statements are true about neutrinos? Okay, neutrinos are basically in beta decay. It turned out the mass or energy wasn't being conserved, so they made this thing that made it so it was conserved. So the antiparticle is antineutrinos. They don't have a charge, and they have almost zero mass, but it turned out mass was not being conserved. So without the strong nuclear force, the nucleus would break apart because of the electrostatic repulsion between the protons. So which of these are true of alpha decay? The nucleon number decreases by 2. No, it decreases by 4. Happens in large or small nuclei? Happens in large. It can happen in both. Alpha particles are made of 2 protons and 4 neutrons. Yes. And the proton number decreases by 2. That. Beautiful. So, we'll end it with the end of topic test for isotopes and nuclei. Cool. We'll do this, and that'll probably be it. So, which of these is not an isotope of hydrogen? That is selenium. What defines an isotope of an element? That would be the number of neutrons, because protons don't change, and electrons are involved in ions. What term is used to describe two specific isotopes of an element? Nuclides. I will give you like a few seconds to be able to think your answer. Just pause it afterwards. Which of these statements are true about different nuclides? They have the same amount of protons, same amount of electrons, and different amount of neutrons, because a nuclide is literally an isotope. How carbon dating works, that is carbon-14. So all living organisms have the same amount of carbon-14 atoms. Once an organism dies, it no longer absorbs carbon, so carbon-14 is radioactive. So it will decay over time. The older the fossil is, the less carbon-14 isotopes it would have. What happens to a nucleus with a strong nuclear force? It would break apart because repulsion, electromagnetic repulsion. And approximately, what distance does the strong nuclear force become weaker? That's 3 femtometers. Yay, femtometers, pretty. Okay, which subatomic particle does not feel the strong nuclear force? Does not feel it. The electron, because it's not in the nucleus. Which particle was discovered, so energy conserved? Antineutrino. It was the antineutrino, because that's the one in beta decay. What kind of decay happens in heavy? Alpha occurs in heavy, beta occurs in anything. Which of these statements are true? Beta minus decay. The proton number increases by 1. Nucleon number does not change. Nucleon number stays the same. And 1 neutron decays into a proton. It would have to, because... Yes. It would have to, because if there's an added proton, that obviously means that. So this has been fun. That was... 25 minutes quick revision session.